Welcome to Naveen Tech Hub.
Let's imagine for a second, your app, your passion project, it suddenly goes viral. I mean, millions of users are flooding your servers all at once. What happens then? Who's playing traffic cop for all those requests? And maybe more importantly, what's stopping the whole thing from just crashing and burning? And, this isn't just some made-up scenario. It's the ultimate stress test for any service. How do you actually manage that chaotic flood of users without everything just grinding to a complete halt? Okay, so let's get into it. The answer lies with two absolutely critical pieces of your system's infrastructure, the load balancer and the API gateway. You can think of them as the unsung heroes of the internet. And really, understanding them is key to building anything that can truly scale. But here's the twist. And honestly, it's the whole reason for this explainer. At a quick glance, they look like they do the same thing, right? They both sit in front of your services and manage traffic. But in reality, they solve completely different problems. And getting that distinction right is what separates a fragile system from a truly resilient one. So to really wrap our heads around this, we gotta zoom out. Let's take a look at the big picture and see exactly where these two components fit inside a modern systems architecture. In most modern applications today, especially the ones built with microservices, a user's request follows a very specific path. It's like a chain of command. First, it hits a load balancer. Then, the load balancer passes it to an API gateway. And only then does it get routed to the correct microservice. Each step here has a very precise job to do. And this analogy just nails it. Think of it like arriving at a massive international airport. The load balancer, that's your air traffic control. It's just directing planes to available runways. It doesn't care who's on the plane or where they're going. But the API gateway, well, that's the entire airport terminal. It's security, it's customs, it's the operations desk all rolled into one. It checks your passport, inspects your baggage, and tells you exactly which gate your service is boarding at. So let's dig a little deeper into that idea. I think the best way to frame this difference is as a tale of two roles. On one hand, you have a simple but very powerful bouncer. And on the other, you have a highly intelligent, very sophisticated concierge. First up is the load balancer. This is our bouncer, and it has exactly one job. Take the incoming line of requests and just distribute them evenly across a bunch of identical servers. The goal is super simple: make sure no single server gets overwhelmed. This keeps your application fast and, most importantly, available. Now, what's maybe even more crucial to understand is what the load balancer doesn't do. It operates purely at the network level. It's thinking in terms of IP addresses and ports. It has no idea what a user is, what an order is, or whether a request is even legitimate. It doesn't peek inside the request. It just forwards it. Okay, so if that's our bouncer, let's meet our smart concierge, the API gateway. This component is way smarter. It acts as a single unified entry point for all of your services, and it understands your application on a deep level. It's basically the front door to all your business logic. And because it's so intelligent, it handles all the really complex tasks. It's what routes requests based on the URL, sending /orders to the order service and /payments to the payment service. It handles security by checking things like user tokens. It can prevent abuse with rate limiting. It can even take one single request from a mobile app, go get data from 3 different microservices, and then stitch it all together into one clean response. So let's just break it down side by side. The role: traffic distribution versus intelligent application routing. The level it works on: network versus application. And what about critical functions like authentication? Well, that's a hard no for the load balancer and a definite yes for the API gateway. The short version is this: load balancers are all about performance and availability. API gateways are about control and intelligence. Now, at this point, you might be thinking, okay, so I have to pick one, right? The bouncer or the concierge. But here's the most powerful insight for building systems that can handle massive scale. These two aren't competitors, they're collaborators. So, faced with your app going viral, which one do you pick? The simple, powerful bouncer or the smart, sophisticated concierge? And the answer, for almost every single large-scale production-grade system out there, is that you use both of them. They form a power couple that gives you the absolute best of both worlds. You get the performance and the intelligence. So what does this actually look like in practice? Well, a typical resilient architecture looks exactly like this. You have a load balancer sitting right at the very front. But instead of routing traffic to your app servers, it's routing traffic to a whole fleet of identical API gateway instances. Then, the gateway does the smart routing to all your different microservices. So why bother with this extra layer? Well, it comes down to 3 huge wins. First, high availability. If one of your API gateway instances fails, the load balancer just instantly redirects traffic to the healthy ones, no downtime. Second, fault tolerance. This setup isolates failures. And third, horizontal scaling. As traffic explodes, you don't try to make one gateway bigger, you just add more gateway instances behind the load balancer. It's an architecture that's built to scale. Now, that load balancer doesn't just randomly throw traffic around. No, it uses specific strategies or algorithms to decide exactly which server gets the next request. For instance, round robin is the simplest. It just cycles through the servers one by one. It's perfect for stateless services. Least connections is a bit smarter. It sends new traffic to whichever server has the fewest active connections, which is great for requests that take different amounts of time. And then you have something like IP hash, which makes sure a specific user always gets sent to the same server. That's super important for things like a shopping cart that needs to remember what's in it. Okay, we've covered a lot of technical ground here, but let's zoom out one last time. Why does mastering this stuff truly matter? Because in modern software development, your architecture, well, it's your destiny. As senior engineer Rajiv Kapoor puts it, understanding these concepts isn't just trivia. It shows that you have the ability to think beyond a single file of code, to really architect systems that are robust, resilient, and ready for massive scale. Honestly, it's the difference between building a garden shed and building a skyscraper. So I'll leave you with this. Your project, your company, your system, it's growing. Users are signing up every single day. The real question you have to ask yourself is your architecture truly ready for what's coming next? Because knowing the difference between a bouncer and a concierge is the first step to being able to confidently answer yes.